Audio Jungle. Audio Jungle.
Novascan application video. Phase 3 operation. Before making a new configuration, we need to select Clear Settings. Click on the main menu, click on the specimen shape of object. Set the length, width and height according to the actual shape of the workpiece. Set the weld parameters, for example, the weld is now a V-shaped weld, select V. Set weld parameters according to the actual welding. Set the probe and wedge in group settings. Set the probe according to the identification of the probe. Set the wedge according to the identification of the wedge. Set focal law. Choose sectorial scan in scan mode. The wave num is set to 2. In the second wave scan, the focal depth is generally set to 1.52 times the thickness of the plate. According to the actual sound beam coverage, adjust the step offset. Make the second wave completely cover the weld and the first wave cover the root of the weld. Adjust the sampling range. Next, calibration. Sound velocity calibration generally select CSKIA test block for calibration. According to the actual radius of the test block, set to ready. Place the probe near the center of the test block during calibration. We can find 2 arc echoes in the sectorial scan area. Move the gate to frame the first radius echo in the middle. Adjust the front and back position of the probe to find the highest echo. Click to get location 1. Then keep the probe still, use the gate to frame the second echo. Click to get location 2. Click calibration value, the sound velocity will display after calibration. If the sound speed is reasonable, click confirm, and the sound speed calibration is completed. When the sound velocity of the workpiece material is known, the sound velocity calibration can be omitted. Next, wedge calibration. Clean up the oil on the surface of the wedge first. We can see the bottom echo in the S display. Use the gate to frame the echo. Drag the VPA line to see if every echo passes through the gate. Click Calculate. Calibration is completed. Click Accept. Delay calibration generally select small holes for calibration. This time we choose the 1.5 mm depth 15 mm hole of the CSKIA test block for calibration. Place the probe above the hole, and you can see the small hole echo from the sectorial scan area. Adjust the gate, frame the gate to the small hole echo. Then move the probe left and right to record the echo of the hole at each angle. When calibration successful, click Accept. Generally when calibrating TCG, the minimum depth of the hole should be smaller than the plate thickness. The maximum depth of the hole needs to be greater than twice the plate thickness. Choose a 20 mm deep hole for the first hole this time. Use the gate to frame the hole echo in the middle. Move the probe left and right to record the echo of each angle. After the envelope is made, click to add points. Make the next point. If below the area, adjust the range. Make sure all angles that need to be calibrated are above the triangle area. TCG curve complete. Click to accept. Adjust range. Adjust the starting point and width of the gate. The starting point of the gate frames the root of the first wave. The gate width frames the entire secondary wave. Scan mode is selected as encoder 1. Set scan range. Select SAC4 layout. Move the scanner to the starting point. Position the probe according to the step offset. Try to increase the PRF as much as possible while ensuring that the clutter wave does not come out. The scanner has a blind spot for starting scanning. The side blind area measured this time is 25 mm. Enter the origin to 25 mm. Click the Start button to move the scanner, then give the encoder a push to observe the direction of the data recording. If the C-scan direction is negative, adjust the polarity in the encoder option. After the data scan is completed, click the Pause button. Save data. Then scan again on the other side. Adjust the polarity of the encoder. Click the Start button to scan. Save date when scanning is completed. Copy the data to a USB drive. Analyze it after the computer is turned on.